In this lecture, we're going to discuss the second definition of an acid, and this is the Lewis acid. It's a molecule or ion. So it's a molecule or ion that can accept a pair of non-bonding electrons, or which are also called lone pairs. Lone pairs are electrons that are not involved in bonding, and they are present in the outer shell. And if you're doing A levels, then they are completely full outer orbitals that are not involved in bonding, and that can form a dative bond. So let's see what I mean by this. Let's say I have an HCl molecule. Now, an HCl molecule would react with water. And remember, water has lone pairs. The oxygen molecule in H2O. So let's say this is the H2O molecule where an oxygen is bonded to two hydrogen atoms. And if you look at the dot and cross diagram, or if you look at the electronic configuration of oxygen, you would notice that it has two electrons in its outer shells, two pairs of electrons in its outer shells that are not involved in bonding. So H2O molecule has exactly two lone pairs. So this is one lone pair and this is another lone pair. Now HCl is going to produce an H plus ion. So that H plus 1 ion would go, and that H plus 1 ion would be attracted to these lone pairs. So it's going to end up forming a dative covalent bond or a coordinate bond with the water molecule, and the other thing that would be left over would be the Cl minus 1 ion. So HCl would lose its H plus 1 ion, and Cl minus 1 would be left behind. Now if you look at this equation, you would notice that it's the H plus 1 ion that is basically the lone pair accepting this entire equation. So let's highlight that, and so it's this H plus 1 ion which in this entire equation is a lone pair acceptor. So we're not going to call HCl. HCl would not be called an acid. It's going to be specifically, it's going to be the H plus 1 ion which is accepting those lone pairs of electrons. Now this definition is going to broaden our the reactions that could be classified as acids and bases. Another reaction to show what a Lewis acid is. So if you look at the molecule of HSO4 minus, there's a lone pair of electrons on the oxygen molecule which are non-bonding electrons, and H plus 1 from water gets attracted to these lone pairs, and it accepts it gets attracted, and it goes and bonds with those lone pairs. So H2SO4 is formed. So what's happening in this reaction is, let me draw what HSO4 ion looks like. So let's first draw this. There's going to be a sulfur forming a double bond with two of the oxygen atoms. Then it would be bonded to an OH group, and there's going to be a single oxygen which would have a lone pair, and it will also have a minus 1 charge. So H plus 1 from water, coming from water, gets attracted to those lone pairs, and when it gets attracted to those lone pairs, it's going to form a dative bond, a dative covalent coordinate bond with those lone pairs, forming H2SO4, which is over here. So in this reaction, if you look carefully, it's going to be this H plus 1 ion that's coming from water and bonding with the lone pairs on this oxygen molecule over here. So it's this H plus 1 that's acting as a Lewis acid. So this over here is your Lewis acid. Now, one thing that we discussed when we were discussing Lewis acids was that the definition of Lewis acid broadens, and it includes a number of reactions that could now be classified as acid-based reactions that were previously, using the Bronsted-Lowry definition, were not classified as acid-based reactions. So we're going to talk about Lewis acids in the formation of metal complexes. Now, metal complexes, let me give you a brief idea of metal complexes if you have not done A levels, is that when aluminium ions are dissolved in water, let's say the aluminium ions are being dissolved in water, what's going to happen is that you're going to have these aluminium ions, and remember aluminium has a 3 positive charge, and it would have all these H2O molecules surrounding it. So all these H2O molecules are surrounding this aluminium ion. So let me draw all of them. So this is how aluminium ions would look like in water. They would be surrounded by water molecules. And what will happen then is that these water molecules, remember oxygen has lone pairs. The lone pairs on oxygen would be attracted to the positively charged aluminium ion. It's going to have a very high charge density. It has a 3 plus charge. So it's going to attract the lone pair of electrons from oxygen. Similarly, aluminium ions are surrounded, so they would also be attracting electrons from below. So a water molecule would be donating electrons from below as well. It would be attracted to the aluminium ion. So from all 6 sides, aluminium ions would be attracting lone pairs from a water molecule. So these electrons get attracted to the aluminium ion. Remember, try to visualize this as a 3D diagram. The darker wedge-shaped bonds are coming out of the page, the dotted bonds are going into the page. Similarly, this water molecule is getting attracted to the aluminium ions, the lone pairs on that water molecule. And the same happens over here. So the shaded darker bonds are the ones that are coming out of the page. So from all 6 sides, you will see water molecules getting attracted to aluminium ions. So this is what a complex is. So aluminium ions, if they are present in water, they're going to be bonded to all the water molecules that are surrounding it. The positively charged aluminium ion would be attracting the lone pairs from oxygen in the water molecules from all sides. So this is what a complex is, and this is what I've drawn over here. This thing over here is the same. So this thing over here, this aluminium H2O6 complex, is this structure that I've drawn over here. So if you look at this reaction carefully, you would notice that aluminium ions are the ones that are accepting lone pairs. So these lone pairs from oxygen are being attracted to aluminium ions, and they are basically accepting lone pairs. And according to that definition, in this particular reaction, aluminium ion is basically acting as a Lewis acid. So all metal complex reactions, they could be classified, or metal complex formation could be classified as Lewis acid and base reactions. So in this particular reaction, it's the aluminium ion that are acting as Lewis acids. In this lecture, we're now going to study what a base is, and specifically we're going to study what a Lewis base is. So a Lewis base is any molecule, or it could be an ion, that could donate a pair of non-bonding electrons. So any electrons in the outer shell of an atom that are non-bonding, or you can call them completely full outer orbitals in the electronic configuration in the outer shell, they are called lone pairs. So any molecule that donates a lone pair, that would be called a base. So I'm going to take the same reactions that we studied when we were discussing Lewis acids. Now Lewis bases. So let's look at this first reaction where HCl is reacting with H2O, and it's forming H3O plus and Cl minus 1. Now we said that H plus 1, because it was accepting a lone pair of electrons, it was getting attracted to a lone pair of electrons. So that was called a lone pair acceptor, or it was called a Lewis acid over here. So this H plus 1 is the Lewis acid, and it's the H2O molecule that's the one that's donating those lone pairs. Those lone pairs are coming from H2O. So this H2O molecule is basically your Lewis base, because it is donating those lone pairs. So H2O over here in this reaction is your Lewis base. Similarly, let's move to the next reaction, and the next reaction was you had HSO4 minus reacting with H2O and producing H2SO4 and OH minus 1. And I told you that HSO4 minus 1 had this structure where oxygen, one of the oxygen in HSO4 minus had a negative charge. It had a lone pair of electrons, and H plus 1 ions coming from water were basically getting attracted to those lone pairs. Now, since H plus 1 is getting attracted to those lone pairs, H plus 1 is accepting lone pairs of electrons, H plus 1 was called a Lewis acid. But based on the definition, it's the HSO4 minus molecule, this O oxygen over here with the lone pairs, that is donating those lone pairs to H plus 1. So HSO4 minus 1 would be your Lewis base in this particular reaction. So a Lewis base is a lone pair donor. Let's study the next reaction we did when we were discussing, and this one was with metal complexes and their formation. And I told you that if you had aluminium ions in an aqueous state in water, so water, the lone pairs on water would be attracted to the aluminium ion, which is positively charged. So these electrons, which are negatively charged, are going to get attracted. So in this reaction, we called aluminium ion was called our Lewis acid because it was accepting lone pairs. But who's the molecule that is losing or donating H plus 1? That's your water molecule over here. All these water molecules, they would be your Lewis acids because they are the ones that are providing or donating lone pairs of electrons.